Right. So whenever you see greatest integer, anytime it says greatest integer, it means we're going to be rounding to a whole number. And seeing a word like greatest might initially make me think that I'm supposed to round up. But after it said greatest integer, what did it say? Less than. Less than or equal to what they gave me. If they say less than, which way do you think they want me to round? Down. We're going to round these down. The reason it says greatest integer less than is because I can think of a whole lot of whole numbers that are less than 2.7. 0 is less than 2.7, and that's a whole number. 1 is less than 2.7, and that's a whole number. It's telling me, by saying greatest integer, I want the biggest whole number that's smaller than 2. So I'm going to round down, but to the closest whole number. Does that make sense? That's what they're trying to say there. So for number 1, 2.7, what would my greatest integer less than that be? 2. What about for number 2? What's weird about that number? It's negative. What else do you notice about it compared to the other 2 in this section? It's already a whole number. So do I need to round it down to get to a whole number? So what would the greatest integer less than or equal to negative 5 be? Negative 5. I didn't need to change it at all. Number 3, I got a decimal, and it's a negative. So it's like taking pieces of both of the problems above. I want to think about a number line real quick because I want to make sure that I'm rounding correctly here, especially when I start thinking about negatives. So like 0, negative 1, negative 2, negative 3, negative 4. Where would negative 3.9 live on that number line? Yeah, like right here-ish. Not quite to the negative 4, but almost. Here's negative 3.9. If I want to round that to the greatest integer that is less than or equal to negative 3.9, I'm going to round this to what? Negative 4. Because I want to round these down. It has to be smaller than what they gave me, unless it's already a whole number, in which case I leave it alone. So far, so good? All right. Second part that goes with 4 and 5. I want the absolute value of what they've given me. What does absolute value mean? Yes, sir. Close, very close. Think about it this way. So last year for fall break, we went down to a place in Tennessee. It was about 300 miles away. It was a drive. Would I ever come back and be like, yeah, we drove negative 300 miles? I went down, though. If somebody's talking about how far they drove, does it matter which direction when they give you? They just tell you how far, right? That's what absolute value is. It's describing distance. Absolute value is the distance away from 0. And when we're talking about distances, those are always what kind of numbers? Positive. Distances are always going to be positive numbers. When I'm thinking about the numbers they gave me, I want to know how far away from 0 is it. So if I think about a number line, how many hops would it take me to get there? I don't care whether I'm going left or right, just how many hops would it take? How far away from 0 is 17? 17 units away from 0. They gave me a positive number, and so I just left it alone. What is the absolute value? What is the distance away from 0 for negative 83? Positive 83. It is 83 hops away. Absolute value, I don't care whether I'm hopping left or right. I just want to know how far. That's what my absolute value tells me. So far, so good? Cool. We are going to be on I want to say it's page 47. I want to talk about something called piecewise functions today. Piecewise functions remind me a little bit of this game that my daughter has. She hasn't played it in a while. But she's got like this puzzle game. She's in first grade, so she's learning how to read. And she has a game to help her put the beginning sound of a word with the rest of the word. And so it's built like a puzzle. It'll have like a picture of a cat. And the first one will have a C on it, and then A-T, and it'll have the body of the cat on it and the head, and she'll match them together. Only she thinks it's really fun, because all the pieces are shaped the same. She thinks it's really fun to take an animal head and stick it on a different ending that it doesn't go to. And so she makes this creature that doesn't exist. So she ends up with like a fat that has a fox head and a cat body. And she just thinks this is hilarious. Piecewise functions kind of remind me of this, where you take these two parts of two different lines and you're like, I'm going to put those together. And they fit together kind of like a puzzle piece in that there's this dividing line between those two. Yes, ma'am. Okay. Page 47. Piecewise functions, when we first look at the equation, it looks terrifying. The equation for a piecewise function looks something like this. This is another place where it reminds me of my daughter learning how to read. When she picks up a book that's too hard for her, she'll read along, read the words that she knows, then she gets to a hard word and she's like, skip that, move on. Students will look at something like this and they're like, and now we're going to, oh, that's too difficult. Skip. So I want to teach you, I want to like demystify these things. Piecewise functions are going to have f of x or a y equals, and then it's going to have this curly bracket. Do you guys see the curly bracket there? If you were thinking about lined notebook paper, how many lines vertically am I looking at inside these curly brackets? How many lines? Like, this would be a line, and then this is a line, and then this. Two. We've got a top piece and a bottom piece, right? When I see two parts in here, I know that on my graph, I'm going to see two different lines graphed here. So there are two parts to the rule. So there are two different graphs. Do you guys see that over here where it's graphed? This graph right here is that equation that comes after the curly brackets. Do you guys see the two distinct separate pieces? Okay. We're going to break down and look at each one of these one at a time. I believe in your books you guys have the text but not the picture, where it's talking about how we graph these piecewise functions. So this is more of a, like, you can check back and forth with your book, but it's more of an eyes up here thing. All right, so I want to look at just the top part first. My eyes are focused on just this piece for right now. And for right now, I'm going to ignore this. There's a couple pieces in here. I have this part right here. And then I have if and an inequality. Do you guys see those two parts? Yes? No? Okay. The part that I circled in blue, This is the rule. This is where the actual graph comes from. Rule to make the line. And it gives me my slope and my y-intercept. The part that comes after the word if, the part that has the inequality, this isn't telling me what shape my line has. I'm not looking here for slope and y-intercept. This tells me where it lives on the graph, which part of the puzzle we're looking at. In this case, because I only have two graphs, I've got a left side and a right side. So this tells me where it lives on the graph. So I want to start by looking at that as we make this make sense. Is that inequality a less than or a greater than? Less than. If it is less than, do you think I'd be looking to the left or to the right? To the left. Less than means left. All right, so right here, less than left. Oops. Left of what? It says less than what? -1. Where is -1 on the x-axis? Where is -1 on the x-axis? Yep, just barely to the left of the origin. So I'm going to draw a little dashed line in here. On all of our piecewise graphs that we make, we're going to draw in these fences based on what my inequality says. So I see x is less than -1, x-axis, -1, I'm going to draw a fence. And because it says less than, I'm only going to look at the left side. So I'm actually going to ignore all of this for right now. I just want to focus on this part. Do you guys see that piece of the line? That came from this rule right here. What's the y-intercept on that rule? I have slope and y-intercept. What's 1? The y-intercept is coming from the 1. What's the slope? It's coming from inside this blue circle. Where do we go to look for slope? It's always right next to what? Always right next to x. +1. I thought I heard -1, and if I misheard that, I apologize. Okay. So the slope is a +1, the y-intercept is 1. If I'm looking only to the left, can I even see the y-axis? Did I cover that part up? I'm only looking to the left of my fence. I don't see the y-axis there. Can we see our slope? Up 1, right 1, up 1, right 1? Yeah. To move from point to point, we're going up 1, right 1, up 1, right 1, up 1, right 1, until we hit that fence. For just a moment, I want to imagine that we could keep going, that I could cross the fence. If I kept going with up 1, right 1, where would it hit the y-axis at? Where would I hit the y-axis at if I could keep going? At +1, which is what we said our y-intercept was. So it tells me my slope, it tells me my y-intercept, and it tells me what part of the graph it lives on. Last thing I want to look at is where it hits the fence. Do you guys see this filled in blue dot right here? That filled in blue dot is coming because I have this or equal to in this inequality. This is a closed dot on the fence. We said this piecewise had how many pieces, how many lines after the curly bracket? 2 lines. We talked about the top one. I want to go look at the bottom one now. So now I'm going to ignore this top piece. Pretend I can't see it. And I'm only going to focus on this part. Which of those pieces is my rule? Which of those would tell me my slope and my y-intercept? Yes, negative 1/3, x plus 10/3. This is my rule. It tells me the slope and the y-intercept. What is the slope of this one? Negative 1/3 right here. What's the y-intercept? Right here. Y-intercept. I don't look in the inequality for the slope of the y-intercept. The inequality only tells me where it lives. It says that I am greater than -1. Greater than, bigger than. On a number line, if I want numbers that are bigger, am I looking left or right? I want to look on the right for bigger numbers. So right of -1. Redraw my fence in here at -1. And I'm going to ignore everything that is on the left-hand side. We're only looking at the right-hand side. Is the y-axis still here? Can I still see the y-axis even though I've blocked out the other part? Mm-hmm. So I can use slope-intercept form to graph this line. My y-intercept is gross. It's 10/3. They plotted that for me. But I can look at my slope, down 1, right 3, down 1, right 3. Where it hits the fence, did they use a closed dot this time? What did they use? They used an open dot. Look at this inequality right here. Does it have the little or equal to underneath it? That's how I know that when it hits the fence, it is an open dot. All right. Let's practice doing one together. We're going to do example 1 in your book. This is still on page 47. Guys, I need phones down and heads up, please. Stick with me. Heads up. Piecewise functions can be tricky if you're not following along with how to do them. So I want to make sure I've got everybody's attention here, because we're going to graph our first piecewise function. Here's the piecewise function that I want to graph. It's made up of how many parts? 2 parts. How do we know that again? Yep. I've got a top and a bottom. Let's do just the top part first. So we're going to graph x minus 3 for all the values of x that are less than or equal to 1. Which of those parts do I look at to tell me where it lives on the graph? Do I want to look at the x minus 3 or the x is less than or equal to 1? This tells me where it lives. I want to go in and draw my fence. I'm going to draw a vertical line that goes through the x-axis. Where will I draw that vertical line at? At 1. X is less than or equal to 1. So I'm going to come over here, and I'm going to draw in my little fence. That's really wide. I'm going to make it just a little bit more narrow. All right, here's my fence. It says less than. Left. Left of 1. Don't scratch anything out on your page, but up here on my screen, I'm going to cover this part up. If I was doing this on paper, I would use another piece of paper to cover it up, or a Post-it note, or my hand. I'm not looking at the right side. I'm only looking left of 1. Come on. Once I know that that's the side that I'm looking at, now I'm going to use the rule to graph it. Is the y-axis still in what we can see? Or did I cover it up? I can still see the y-axis. So I'm going to use slope-intercept form to graph this. What is the intercept, the y-intercept right here? -3. Y-intercept right here. So I'm going to go and graph that on the y-axis, right down here. Plot my point. What's the slope? 1. There's an invisible 1 right here, and so I have a slope of 1. So I'm going to go up 1 and right 1. I hit my fence when I do that, don't I? Should I use a filled-in dot where I hit the fence, or should I do an open dot? Filled in. Why? Because it has that or equal to there. Because of this little or equal to, this is a closed dot, a filled-in dot on the fence. So filled-in dot right here. Do I have enough points that I could grab my straight edge and sketch this in? Yep. Or I could get a couple more by doing everything in reverse. If I go down 1 and left 1, I get more points that are on that same exact line. And then I can grab my straight edge and I can trace through those points. And it would go forever in this direction because it lives everywhere on the left side of this fence. Are you guys okay with how I drew this so far? All right. Now I want to come down here and graph this guy. Let's look at those pieces. We're going to graph 2x for x is greater than 1. Which side am I talking about now if I'm saying it's greater than 1? Right side. Where it lives on the right of 1. So I'm going to get rid of this. I only want to be looking on the right side now. So just for right now, I'm going to cover this up with my hand or a Post-it note so that I can look just on the other side. Can I see the y-axis anymore? Not really. I mean, I see where it's supposed to be. It's like somewhere over here, but that fence was not on my y-axis. So I can't use slope-intercept form because I can't plot the intercept. It doesn't live where the y-axis is. So I'm going to have to use one of those other methods that we talked about. We're going to use a table here. going to make an XY table. And I have to pick things off the x-axis that I can actually see. Where did we put our fence at? At 1. I want to know what happens where it hits that fence, so I need to make sure that's on there. Give me a couple more numbers that would be on the x-axis over here. 2. Anything else? 3. Can put 4 on there. Everything that's bigger than to the right of 1. And now I need to find my y's. So I'm going to use this rule right here. Here's my rule. So I'm going to take 2 and I'm going to substitute in the value that they gave me for x. What's 2 times 1? 2. So that's the first ordered pair. 1, 2. This is how I found the y part. And then I'm going to repeat that, only this time I'm going to put what in the place of x? Now I'm going to put 2 in the place of x. What's 2 times 2? 4. I wrote down 4 and I should not have. There we go. For the next number, what do I put in the place of x? 3. 2 times 3? 6. And what would I substitute in to find the last y value? I'm going to substitute in 4. 2 times 4? 8. One of these dots is really, really special, or one of these ordered pairs. It's this guy right here. Because when I go to plot it, where does it land? What was I calling this little dashed line here? It lands right on my fence. This is on the fence, and I need to know whether I'm going to use a solid filled in dot or an open circle. How do I make that decision? Where's my inequality here for this part? Right here. I don't have that or equal to underneath it, and so this is going to be an open dot on the fence. So I'm going to go and plot that point. 1, 2, open dot on my fence. Can I fit 2, 4 on this graph? Yeah, 2, 4, it's right here. Can I fit 3, 6 on this graph? Not really, it's just barely off of here, right? Can I fit 4, 8 on here? No, it's way too far off my graph. Gentlemen, heads up for me, please. I would grab my straight edge to trace this line in. Trent, head up for me, dear. I'm going to grab my straight edge. Would I draw a line that looks like this? Where does it have to stop at? Yeah, has to stop at the open circle, has to stop at my fence. That is my piecewise graph. A lot of times when I've done this with students in the past, I'll pass out Post-it notes so that we can cover up and only look at the one part. You draw that in and then you flip the Post-it note over and only look at the other side. You can cover it up with another piece of paper or with your hand, but you need to figure out where your fence is, and that's coming from your inequalities here. All right. Last thing we need to do is to analyze our key features. Key features would be things like domain and range. Do I have any x or y intercepts? Is it increasing or decreasing? Is it continuous? Like, what's going on with the graph? How would I describe it to someone else? Let's start with intercepts. Anywhere on here, Does it touch the y-axis? Yes. Where does it touch the y-axis at? Yeah, right down here at -3. So I do have a y-intercept. This is going to be at the top of the next page in your book. So where it's talking about key features is on page 48. Y-intercept is at 0, -3. Does this ever touch the x-axis? Does it have an x-intercept? No. I have this fence in here, but that's really like an invisible fence. That's not part of my graph. That's not either one of these lines. And neither one of these touch the x-axis at all. So I would say none. It doesn't have any x-intercepts. Increasing and decreasing. We read this like a book. We're going to read this graph like a book. When you're reading sentences, what side do you start on? Left. I'm going to start on the far left side of this graph. And for the graph that I drew in, the lines that I drew in, this is as far left as it goes, right? I'm going to move to the right, and I want you to tell me whether my finger is going up, increasing, or going down, decreasing. Increasing. I get to right here, and I have to take an elevator up, right? Take my elevator up to here. And what's happening here?
It's going up.
It's going up. It's still increasing. So is this graph increasing anywhere? Yes. Increasing? Yes, it is. Where? Did my finger ever turn and go down? It's increasing everywhere. It's increasing for all the values of x. As I move from left to right, my x-axis goes from left to right, and the whole time my finger was going up for all values of x. Or we could say all real numbers. That would work too. Did my finger ever go down? So is it decreasing at all anywhere? No. So where it said decreasing, I'd say nope. And if it's not decreasing, then I don't need to describe where it's doing that at, because it's not happening. So far, so good? Last things we need to talk about are domain and range. Those were the first things on my list, but those are a little bit harder to visualize. So I'm going to do my best. Is domain talking to me about x's or y's? X's. So I'm scanning from left to right, looking for any gaps. From here to here, like all the way up and down, from here to here, I can trace on the graph, right? And while I have to take an elevator, I'm going straight up to the next part, right? If I'm going this way, would this be considered a gap?
No.
No. I'm going straight up, so there's no gap. I stayed in place and it took me up. And then did we continue on?
Yeah.
So I can get from the left-hand side to the right-hand side without having to pick up my finger really, right? I gotta hop on an elevator here, but then I can keep going. My domain is all real numbers. All real numbers. For the range, am I still going from the left to the right? No, because that's for my x's. My x-axis goes left and right. I look this way for the domain. Which way would I be scanning this for the range? Up and down. So if I scan this up and down, does my graph exist here? Does my graph exist here? There's gap. What about up here? So it exists down low, it exists up high, but it does not exist in the middle. So from right here and down, from right here and up, but we have a gap right here. I have to find a way of explaining that there's no y values here. There's no part of the graph in here. I'm going to write this range using interval notation. That was the ones with the parentheses. Do you guys remember when we practiced that? We always want to start with the lowest value, the smallest value. So I'm going to start at the bottom. Does this keep going down-ish forever? So how would I describe the smallest y value if it keeps going downish and downish and downish and downish? Negative infinity. So I can go from negative infinity all the way up to where? -2. Is that a closed dot or an open dot? Closed. So I use a bracket. If it's a closed dot, I use a bracket. And then I have this gap. Do you guys remember how we talk about a gap? Union. I use a capital U for a union. And where does my graph pick back up again? +2. Open dot or closed dot right there? Open. So I use a parenthesis. And then from there, it goes up or up-ish forever, right? How do I say that? Infinity. So there's my range. Another way I could have said that is my y's are either less than or equal to -2, or they're greater than +2, but nothing in between. So it's less than -2, or y is less than or equal to -2, or y is greater than 2. This would be another way of writing my range right here. That is a whole lot on one screen. And there wasn't a lot for you guys to actually practice writing down in your books. I have an example problem that is very similar to the way I'm going to ask you to do this on the homework. I'm going to put it up on the screen. This one's not in your books. And this is where we're going to stop for today with this one, okay? Multiple choice for the first part, fill in the blank for the second part. When you look at this piecewise guy, how many lines does it have? 3 lines. So I would be expecting a graph with how many parts? 3 parts. And it needs to be stitched together like a puzzle. Which one of these do I know I can throw out right away because it's not been stitched together, it's just all on top of each other?
D.
D. Get rid of that one. Piecewise never looks like this. So I'm going to cross that one out right now. Nope.
Ain't B and C the same thing?
Ooh. Very close to the same thing. A, B, and C are all super close, aren't they?
Yeah.
There's tiny little differences between them. Who can pick out what the differences are?
Can I pick them out?
Yeah.
Graph A, it got a closed circle in the bottom corner. And then graph B got an open circle at the bottom, but it don't got a circle in the corner shape.
Yeah. So like right here.
And then graph C got 2 open circles.
2 open circles here. Here I have an open and a closed. Here I have an open and a, I don't even know. I don't see a dot, right? When you see 2 pieces that have come together and they've like been stitched together like that, and you don't see an open dot, that means it's a closed dot. They just didn't draw it. If it's an open dot, they have to show it to you. So if you see where they've stitched it together, that's a closed dot there, even though they didn't draw it. And I'm glad they did it like this because on the homework it's also like that where they'll stitch it together, and if they touch, you won't see a closed or open dot there. All right, so now we got to figure out which of these 3 graphs that look almost identical goes with this. What is it that decides closed or open dots? Where do I look? How did we decide whether we were going to fill it in or not? Was it coming from the rule? Or was it coming from the address where it lives? Where it lives, address. What do you notice about this one? It doesn't have a little line under it, which means I would expect a closed dot or an open dot. Open dot. Should I be looking to the left or the right of this number? For a less than, I'm going to look left. I'm going to look left of -2 on the x-axis, so that would be right here. And I'm looking at this part because this is to the left. Did they use an open dot here? No. What about here?
Yes.
They had an open dot. What about over here? So can I use that to narrow it down? Do I know the right answer right now, or is there one that I can throw out?
You could throw out graph A.
I can throw out graph A. Remind me why again?
Because your answer got to have a closed circle.
Yeah,
Open circle.
an open circle. I knew what you meant there, but yeah. This should be open. Coming from right here. All right, so what's the difference between these two? They both have open right there. How am I going to narrow it down even more?
Wait, didn't that one not have a circle at all?
This one right here?
Yeah.
So remember, when they've stitched a graph together and they don't show you a closed dot, it's closed. If it's an open dot, they have to show you that. That's the only difference between these two graphs, right? How am I going to decide whether it should be open or closed? Let's look here. What does it tell me about this dot? Closed. And this dot? Closed. And it's in between what two numbers?
2.
-2 and +2. Here's -2, here's +2, and it said it's supposed to be what kind of dot on both sides? Closed. Is this one closed on both sides?
No.
It's closed on this side.
Why didn't you see it?
That one's open over there. This one's closed. That one's open. What about this graph? They're both closed. So which one is it? It's B. Should be closed. Tell me what it would look like if I put a closed dot on top of an open dot. If I graph something and I graph an open dot and then later I see it's supposed to have a closed dot on that exact same spot, what's it going to end up looking like? A closed dot. So when I get down here and I see this fence and I was like, oh, that should be open. We already put a closed dot right at that spot. That's okay. It's going to look like a closed dot. Last thing, domain and range. I'm only looking at this guy right now. Could I move from the left to the right, even if I had to take some elevators? Could I move from the left to the right on this graph without stopping? Yeah. I can start over here. I'd have to take an elevator up. I can go over here. I can go down. Can I get from one side to the other? Everywhere. Yes. I can take elevators straight up, and that's okay. But what I can do, elevators like go like this. So if I have to jump, that would be different. I don't have to jump over. I can take an elevator straight up. My domain is going to be all real numbers because I could get from one side to the other. All real numbers. Now let's look for our range. Which way am I scanning for the range? Up and down. Is there anything that's pointing downish? Yeah. This side it's pointing down. This side's also pointing down, right? There's graph that goes from here to here. Is there a graph that goes from here to here?
No. Oh, yeah.
It's over here, but there is a part of a graph that goes there. Is there a graph that goes from here to here? Yes. What about up here? There's no graph up there. All of my graph is below that. And I can fill in every single little spot that I'm looking at. All of my y values are smaller than what? This whole graph lives below what? 3. 1, 2, 3. That's the highest it ever goes. We never go above that. So my range is y is less than or equal to 3. Or if you wanted to do that using interval notation, from negative infinity, because it does go down, up to 3, and then it stops. All right. That's as far as I'm taking us today. We're going to continue talking about piecewise functions tomorrow, where we will talk about something called a step function. What does a step function make you think of?
Stepbrother.
Stepbrothers. Anything else? Stairs.
Oh, yeah.
My step function is going to look like stairs. Only it's going to look like cool futuristic stairs, to where it's like just the flat part of the step in space without this part, without the rise part. So it's going to be a step and a step and a step. Are steps always the same size? Like when you walk up a staircase, are they always the same height?
No.
No. Most of the time they are.
They got the little part where it's big, and then you gotta go up. You see what I'm saying? It's like,
Yep.
this girl off big.
Well, and I've even seen it like some playgrounds. They'll have like a couple small steps and then a big step and then a couple small. They don't have to be the same distance apart this way. My steps won't always be the same distance apart. The homework is up. It's not going to be due until Monday. I have to get in and change the due date, so don't worry that it says it's due on Friday. I put in the wrong day. Homework's due on Monday. If you guys want to get started on it, you're more than welcome to. If you want to wait another day or so to get started on it, that is perfectly fine. Yes, sir. Absolutely, you may.